Albert Einstein once said, "If bees disappeared from the face of the earth, humanity would have no more than 4 years left."
Some say Einstein never actually said it. Maybe he didn't. But here's what's not disputed: scientists say exactly this. Without bees, the planet's food chain collapses completely within a few years. And bees are disappearing right now, all over the world. And most people aren't even thinking about it. Today we're talking about a creature without which life on Earth, as we currently know it, is impossible. A creature that produces a substance that doesn't spoil for thousands of years. A creature capable of making collective decisions that are smarter than many human organizations. We're talking about the bee. Let's start with scale, because the first thing most people get wrong is how many kinds of bees actually exist. There are roughly 20,000 species of bees on this planet. 20,000. Most people know one, the honeybee. The other 19,999 species live their lives quietly, alone or in small groups, pollinating plants, building nests in the ground, in hollow stems, in cracks in rocks, invisible to us. The honeybee, Apis mellifera, is the one humans keep. It originated in Africa and Eurasia, and over thousands of years of human activity, it has spread across the entire world. It's the bee this video is mostly about. The bee is an insect. Order Hymenoptera, family Apidae. Its closest relatives are wasps and ants. That's not a coincidence, all of them are social insects with highly organized colonies. A worker honeybee is about 15 millimeters long and weighs around 120 milligrams. You could set one on your thumbnail and barely feel it. And yet it is part of one of the most complex biological systems that has ever existed on Earth. The bee's body has 3 sections: head, thorax, and abdomen. On the head, compound eyes allow it to see in the ultraviolet spectrum. Flowers that look plain and single-colored to us appear to a bee as vivid maps with landing strips pointing directly to the nectar. Evolution made a deal: the flower signals the bee carries the pollen. The antennae are multifunction sensors, they detect smell, temperature, humidity, and air vibrations simultaneously. A bee continuously feels the world around it through its antennae. On its hind legs, pollen baskets, specialized concave structures ringed with stiff hairs. The bee brushes pollen from its body, moistens it with nectar, and presses it into the basket. A loaded bee flies back to the hive with bright yellow or orange spheres bulging from its hind legs. Those are the baskets, packed to capacity. Only females have stingers, workers and the queen. Drones, the males, have no stinger at all. The worker bee stinger is barbed like a fishhook. When it stings, the barb catches in skin, and as the bee tries to fly away, it tears out part of its own abdomen along with the stinger. This kills it. A bee stings only when it has no other option, and it pays with its life. The queen is the only bee in the hive with a smooth, unbarbed stinger. She can sting multiple times without harming herself, but she almost never does, only when directly threatened or when fighting another queen. One hive is not simply a pile of bees. It is a single organism. Biologists use the term superorganism because a hive functions as one unified living thing, where each individual bee performs the role of a separate organ. A typical hive holds 40,000 to 80,000 individuals. At the height of summer, it can reach 100,000. Among them, one queen. Her single function is reproduction. She lays up to 2,000 eggs per day during the active season, almost without pause. She can live up to 5 years, a longevity record for the bee family. Worker bees live about 6 weeks in summer. Several hundred drones, males, whose only purpose is to fertilize a young queen. They don't work, don't collect nectar, don't guard the hive. They eat and they wait. In autumn, when their role is fulfilled, the worker bees simply expel the drones from the hive. Outside it's cold. The drones die. This isn't cruelty, it's precise calculation. There's no reason to feed extra mouths through the winter. All other bees are workers, females with undeveloped ovaries who do everything: build comb, collect nectar and pollen, produce honey, feed larvae, maintain temperature, guard the entrance, remove debris, and dead bees, produce wax and propolis. The most remarkable thing about worker bees is their age-based career system. A bee just emerged from her cell spends the first days cleaning, scrubbing cells. Then she becomes a nurse, feeding larvae. Then a builder, secreting wax. Then a guard, stationed at the hive entrance. Only in the last 2 weeks of her life does she become a forager, flying out for nectar. Every bee knows what she's supposed to do, without orders from above, without managers. The queen doesn't run the hive in any conventional sense. She doesn't issue commands. Coordination happens through chemical signals, pheromones, and through a remarkable mechanism that deserves its own attention. In 1946, Austrian biologist Karl von Frisch discovered something extraordinary: bees communicate through dance. A bee that has found a nectar source returns to the hive and performs a dance on the surface of the comb. The shape of the dance, its duration, and the angle it makes relative to vertical encode 3 parameters simultaneously: the direction to the food source relative to the sun, the distance to it, and the quality of what's there. Other bees observe the dance and fly unerringly to the indicated location. For this discovery, von Frisch received the Nobel Prize in 1973. Bees are among the very few creatures on Earth that use a symbolic language to convey information about objects that aren't present. That's a capacity we tend to think of as exclusively human. Honey is not simply a sweet substance. It is the result of a complex biochemical process that takes several weeks and requires the coordinated effort of thousands of individuals. Nectar is the raw material. A forager bee sucks it from a flower using her proboscis and stores it in her honey stomach, a separate organ, completely disconnected from her digestive system. The honey stomach holds about 40 milligrams of liquid. To fill it, she visits between 100 and 1,500 flowers. Chemical transformation begins immediately inside the honey stomach. Enzymes, primarily invertase, begin breaking sucrose from the nectar into glucose and fructose. When she returns to the hive, she passes the nectar to a house bee through a direct mouth-to-mouth transfer. That bee places it in her own honey stomach, processes it further with enzymes, and passes it to the next. This chain repeats several times. Gradually the water content drops from 80% down toward 20%. Then the partially processed nectar is placed in comb cells and ventilation begins. Bees fan their wings, creating a steady airflow. Evaporation continues. When the moisture content drops to 18%, the honey is ready. The bees seal the cell with a wax cap. To produce 1 teaspoon of honey, bees must collectively fly the equivalent of twice around the Earth's equator, roughly 120,000 kilometers, and visit approximately 2 million flowers. In her entire 6-week lifetime, one worker bee produces about half a teaspoon of honey. If you've eaten a spoonful, you've consumed the work of 12 lifetimes. Honey found in the tombs of Egyptian pharaohs, 3,000 years old, was still perfectly edible. Several factors combine to make this possible. The extremely low moisture content prevents bacteria and mold from reproducing. The acidic pH, around 3.5, creates an environment hostile to most microorganisms. And the enzyme glucose oxidase continuously releases hydrogen peroxide, a natural antiseptic. Honey is an antimicrobial product with an essentially unlimited shelf life. In medicine, honey has been used for millennia. The Egyptians applied it to wounds. During the First World War, when medical supplies ran short, honey was used as an antiseptic for wound dressings. Modern research confirms that honey, particularly manuka, is effective against certain bacterial infections that have developed resistance to antibiotics. Honey is only one of what bees give the world, and it may not even be the most important. Wax. Worker bees secrete it from specialized glands on the abdomen. To produce 1 kilogram of wax, bees must consume approximately 8 kilograms of honey. Wax is the structural material of the hive, and for thousands of years humans have used it for candles, cosmetics, medicinal salves, polishes, fabric waterproofing, and food preservation. Propolis. A resinous substance bees collect from tree buds and bark, mixed with their own enzymes. Inside the hive, it functions as an antiseptic and sealant. Bees fill every crack with it, coat the walls, and neutralize foreign objects. If a mouse enters the hive and the bees can't remove it, they encase the entire carcass in propolis, natural mummification. Without propolis, a decaying mouse would infect the entire colony. Propolis contains over 300 biologically active compounds. Medically, it demonstrates antibacterial, antiviral, and antifungal properties. Some laboratory research suggests efficacy against certain cancer types, though clinical trials are ongoing. Royal jelly. A special substance produced by the glands of young worker bees. All larvae receive it for the first 3 days of life. But the larva chosen to become a queen receives royal jelly throughout her entire development, without restriction. And this is the only thing that distinguishes a queen from a worker bee. Genetically, they are identical. The difference is entirely in diet. The queen lives 5 years. The worker lives 6 weeks. The queen is twice the size, with fully developed ovaries. All of this comes from royal jelly, not genetics. Royal jelly contains a unique protein called royalactin that triggers a hormonal cascade leading to queen development. It's one of the most studied examples of epigenetics, when not the genes, but their expression, determines what an organism becomes. Venom. Apitoxin. A single sting delivers about 0.1 milligrams. For most people, a minor irritation. For people with allergies, potentially lethal. Apitoxin contains melittin, its most studied component, which shows anti-inflammatory properties and is being investigated as a potential agent against certain viruses and tumors. Apitherapy, treatment using bee venom, has been practiced for thousands of years. Modern medicine approaches it with caution, but research continues. This is the most important thing bees do. Not honey. Pollination. About 80% of all flowering plant species on Earth depend on insect pollination. Most of them depend on bees. Roughly 1/3 of all the food humanity consumes exists because of bee pollination. More specifically, apples, pears, cherries, apricots, peaches, plums, all require bee pollination. Cucumbers, zucchini, pumpkins, bees. Almonds are 90% dependent on bees. Strawberries, raspberries, blueberries, blackberries, bees. Coffee, bees. Cacao, bees. Sunflowers, bees. Grain crops like wheat, rice, and corn are wind-pollinated and don't depend on bees. That's the several years scenario, humanity theoretically surviving on bread and rice, without fruits, vegetables, nuts, chocolate, or coffee. But it doesn't stop there. Without bees, it's not just cultivated crops that disappear. Wild flowering plants disappear, the plants that form the foundation of entire ecosystems. After them go the insects and birds that feed on those plants. Then the predators that feed on those insects and birds. The chain collapses from the bottom up. One honeybee colony pollinates between 5 and 10 square kilometers of land per season. The economic value of bee pollination to global agriculture is estimated at around $250 billion annually. That's a service nature provides for free, as long as the bees are alive. In the United States, pollination by bees is valued at $15 to $20 billion per year. Every almond orchard in California, the world's largest producer, is entirely dependent on rented hives. Farmers pay beekeepers to truck in hives at flowering time. Without this, there's no harvest. When bee populations disappear from a region, people sometimes resort to pollination by hand. In Sichuan province in China, where uncontrolled pesticide use eliminated local bees, farmers pollinated apple orchards with small brushes, flower by flower. This is not a hypothetical future scenario. It happened. It is happening right now. Since the early 2000s, a sharp decline in bee populations has been documented worldwide. The phenomenon is called colony collapse disorder, or CCD. Bees simply leave the hive and don't return. No dead bodies are found. The hive just empties. In the United States between 2006 and 2008 alone, around 30% of all bee colonies died. In some states, more than half. Similar patterns emerged across Europe and Asia. The causes are multiple, and they act simultaneously, compounding each other. Pesticides, neonicotinoids in particular, a class of insecticides widely used in agriculture. They don't kill bees outright. They act on the nervous system chronically, disrupting navigation, memory, and the ability to learn. A bee exposed to low doses of neonicotinoids loses the ability to find her way back to the hive. She simply doesn't return because she can't find home. This is colony collapse disorder. The European Union banned the 3 most dangerous neonicotinoids for outdoor use in 2018, an important step. But in most countries around the world, these substances are still in use. Varroa. The mite Varroa destructor, a parasite that arrived from Asia. It feeds on the fat body of bees and their larvae, weakens the immune system, and transmits viruses. Today, Varroa is present in virtually every hive on the planet, with the exception of Australia and a few isolated territories. Without regular treatment, the mite destroys a colony within 2 to 3 years. Habitat loss. Monoculture agriculture, endless fields of wheat or corn, is a food desert for bees. No diversity of flowering plants means no food. Urbanization wipes out meadows and flowering roadsides. Wild bees, which don't have managed hives, lose their nesting sites. Climate change is shifting the timing of flowering. Bees tied to specific seasonal cycles find themselves out of sync with the flowers, arriving earlier or later than when nectar is available. Pathogens. Fungal infections, viruses, bacteria. Bees already weakened by pesticides and varroa resist disease less effectively. Infections spread faster. Year 1. Flowering agricultural crops produce drastically reduced harvests. Fruits, berries, and nuts become scarce. Prices rise sharply. Farmers attempt to switch to hand pollination and drone-assisted pollination, but these are incomparably slower and more expensive. Years 2 and 3. Food shortages grow. Many wild flowering plant species begin to disappear. The insects and birds that depend on them follow. A cascade collapse of ecosystems begins. Years 4 and 5. The global food production system faces collapse. 1/3 of humanity's diet has vanished or become inaccessible to most people. This is not science fiction. These are assessments from serious scientific bodies, the FAO, the UN, the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services. There is another side to this scenario: humanity adapts. Robotic pollinators are already being developed, tiny drones with adhesive fibers mimicking a bee's pollen collection mechanism. Artificial pollination systems using pollen sprays are being researched. Self-pollinating crop varieties are being bred. But all of this is expensive, slow, and partial. Replacing 2 billion years of evolution that created a perfect pollination system isn't something you do in a few years. Bees have existed for approximately 100 million years. The oldest known bee fossil was found preserved in amber of that age. Dinosaurs were still walking the earth when bees were already pollinating flowers. A bee flies at around 24 kilometers per hour and travels up to 3 kilometers from the hive in a single trip, making several trips per day. The total flight distance of one bee over her lifetime is roughly 800 kilometers. Her wings beat approximately 230 times per second. That's the buzzing sound you hear, a frequency of about 230 Hz. The queen produces a different, lower sound, around 208 Hz. Bees can distinguish these frequencies and respond to them differently. Bees can count to 4. Experiments have shown they can associate a quantity of objects with a symbol and select the correct answer, placing them alongside birds and certain primates in terms of numerical cognition. Bees can recognize individual human faces. This was discovered accidentally during memory experiments. Bees were trained to associate a photograph of a specific face with a food reward. They remembered and distinguished between faces with around 80% accuracy. The brain making these distinctions weighs approximately 1 milligram, less than a single comma on a printed page. It contains about 1 million neurons. A human brain has 86 billion. The information density being processed by that milligram is extraordinary. Bees make collective decisions through a process scientists call swarm democracy. When a colony needs to relocate, several hundred scout bees fly out to find new sites. Each one returns and performs a waggle dance in support of her chosen location. The better the site, the more vigorous the dance. Other scouts fly to inspect sites and join the dance for whichever they prefer. Gradually, a majority forms around one option. The swarm flies to wherever the majority of scouts voted for. No single bee makes the final decision. No individual has veto power. Pure horizontal democracy, in a creature without a language and without what we'd call a brain. In winter, bees don't hibernate. They form a cluster. The queen sits at the center. Around her, thousands of bees vibrate their flight muscles without moving, generating heat. The temperature at the cluster's center stays around 35 degrees Celsius even in the hardest frosts. Bees on the outer edge gradually work their way inward to warm up, while warmed bees move outward. They heat each other. One hive produces between 20 and 50 kilograms of honey in a summer. The colony itself consumes around 20 kilograms through the winter. The rest is what the beekeeper takes. This is why beekeeping is possible without harming the colony. Bees produce more than they need. One of the most dramatic processes in nature is the changing of queens and the swarm. When the existing queen ages or the colony becomes too large, worker bees build queen cells, large specialized cells hanging vertically at the edges of the comb. New queens develop inside them. The first queen to emerge immediately tours all the remaining queen cells and stings her rivals through the cell walls before they can emerge. If two queens emerge simultaneously, they fight to the death. The victorious young queen then takes her mating flight. She rises high into the air, up to 30 meters, and mates with 10 to 20 drones from different colonies. Each drone dies immediately after mating. His reproductive organs remain inside the queen. But the queen receives a lifetime supply of sperm, enough for up to 5 years of egg laying. She will never mate again. Meanwhile, the old queen flies out of the hive with roughly half the colony. This is the swarm, a dense, living cloud of 10,000 to 30,000 bees that temporarily settles on a branch or fence post as a hanging cluster. This is not aggression. It is relocation. A swarm is actually among the safest bee encounters. They have no hive to defend and are entirely focused on finding a new home. This is exactly when the scouts go out, and when swarm democracy plays out. The honeycomb is one of the most perfect architectural structures in nature. The hexagonal cell isn't an arbitrary shape. Mathematically, it is the optimal geometry, maximum enclosed volume for minimum material used. Scientists formally proved this in 1999, when the honeycomb conjecture, a mathematical problem that had been open for nearly a century, was finally solved. Bees arrived at this solution long before the mathematicians did. Cell walls are about 0.07 millimeters thick. Yet 1 square meter of honeycomb bears a load of 25 kilograms. The ratio of structural weight to supported load is among the best in nature. The cells are also not horizontal, they're tilted slightly upward, at around 13 degrees. This isn't accidental. The incline prevents honey from draining out before the cell is capped. Bees have accompanied humanity from the very beginning. Cave paintings in Spain made 8,000 years ago show a human figure extracting honey from a wild hive, one of the oldest documented records of human interaction with bees. In ancient Egypt, the bee was a symbol of royal power, appearing in the hieroglyphic title of the pharaoh. Egyptians kept hives in ceramic tubes and transported them up and down the Nile following the flowering seasons. This was the first industrial beekeeping in history. In ancient Greece, honey was the food of the gods. Ambrosia, the substance said to confer immortality, was described as something supernaturally sweet. Hippocrates used honey in treating wounds and intestinal disorders. In medieval Europe, honey was the primary sweetener before sugar became available. Beekeeping was central to monastery life. Beeswax went to church candles, making bees literally part of religious practice. Mead, honey wine, is one of humanity's oldest alcoholic beverages. Traces of mead have been found in Chinese vessels 9,000 years old. In Scandinavian mythology, honey mead was the drink of warriors in Valhalla. During the First World War, when sugar supplies fell short, Britain mobilized beekeepers to increase honey production. In besieged cities during the Second World War, hives were kept on building rooftops. Napoleon Bonaparte adopted the bee as his personal symbol, representing industry, organization, and collective strength. Bees were embroidered on his coronation mantle. Scientists study bees not only for their protection but for inspiration. Swarm intelligence algorithms, mathematical models based on scout bee behavior, are now used in route optimization for logistics, load distribution in computer networks, and the coordination of drone swarms. The bee's democratic decision-making process became so efficient it was converted into a computer algorithm. Robotic pollinators already exist. Tiny drones with artificial bristles capable of transferring pollen from flower to flower were developed by a Japanese research team as early as 2017. Still far from the scale of living bees, but the work continues. Researchers at Harvard are developing swarms of micro-drones called robo-bees, each the size of a coin, that are learning to fly in coordinated groups, synchronize movements, and perform cooperative tasks. The inspiration, the bee swarm. And one more discovery that emerged from studying bees' enemies, wax moth larvae, which parasitize bee colonies, turned out to be capable of breaking down polyethylene. Scientists believe the enzyme that allows them to digest beeswax works on plastic as well. This discovery was made because someone was studying what harms bees. A bee the size of a fingernail, weighing as much as a paper clip, turns out to be at the center of multiple scientific revolutions simultaneously: ecology, mathematics, robotics, medicine. All of this from one bee. We're used to not noticing the bee, waving it away, being afraid of the sting, thinking about honey at breakfast without thinking about where it came from. But every piece of fruit you eat passed through a bee. Every flower you see exists because of a bee. Every tree in an orchard, every berry in a forest, the result of this work. 100 million years of it. While dinosaurs were born, lived, and died, bees flew from flower to flower. While civilizations rose and fell, bees built their own. While we debated politics and technology, bees did what makes life on Earth in its current form possible. One creature weighing 120 milligrams, with a brain weighing 1 milligram, without which 1/3 of the world's food disappears. If you want to do something after watching this video, plant flowers, any flowers. Don't cut dandelions too early in spring. They are the first food available to bees after winter. Avoid pesticides in your garden. If you find a swarm in or near your home, don't kill it, call a beekeeper. They will take the swarm alive. That's not sentimentality. It's pragmatism. They need us to leave them alone. We need them to exist. The last time you saw a bee, when was it? Write in the comments. I'm genuinely curious. 100 million years. Quietly, without fanfare, without any claim on our attention. It's probably time we started paying some.